All right, welcome back, Algebra 2. So example 3 says find all the solutions of the polynomial. So we have 4x cubed equals x, so we're still going to be factoring these, following our rules, of course. The first is to find the GCF if you can. Second, then, is to find a special pattern if you can. And third, we leave for last, which is guess and check. So first things first, to do these, you need all things equal to 0. So if we have equal to x, well, we got to get that x on the other side. So let's subtract x, subtract x. Now be careful, you cannot actually subtract x from 4x cubed because they are not like terms. This would need to be x cubed if we were going to be able to do that. So we just have 4x cubed minus x out back equals, and then those cross, and you get 0. So now let's see if on the left-hand side we can find a GCF, which we can. There's an x in each of these I can take out. So we have x times the quantity, 4x, and then we had 3, took 1, so that'd be x squared. And then we had an x here and we took it, so now it's not just completely gone, and there's a 0 there, but it's gone, and we had a coefficient of 1, so we need a 1 here, so equals 0. Mentally checking to see if we can FOIL that back out. We have x times 4x squared equals 4x cubed. X times a negative 1 is a negative 1x, so we have done it. Now, just because we found a greatest common factor, don't stop there. Check to see if there's special patterns on this stuff for the inside. Which, it appears, if I square root 4x squared, I can do that. If I square root 1, I can, so I can actually use a special pattern here. So let's go ahead and do that. So we have x on the outside, and then when I square root 4x squared, I get 2x. So that's my first polynomial, 2x here, and then equals 0, of course. And then if I square root 1, I need a 1 and a 1 with no middle term. That means I need a plus, and I need a minus. Okay? Checking inside again, can I factor further? Well, no, because these are linear binomials, so I can't go any further. So let's go ahead and set each of these things. We have 3 things, remember, equal to 0. So we have x equals 0, and we get 2x plus 1 equals 0, and then we get 2x minus 1 equals 0. So we're breaking it apart here, setting them all equal to 0. Well, this one's done. Obviously, x is going to be 0 here. Here we minus 1, we get 2x equals negative 1. We divide each side by 2. And we get x equals negative 1/2. Over here we add 1. We get 2x equals 1. We divide each side by 2. And we get x equals 1/2. So our 3 solutions, which we should have expected 3 solutions based on our degree here, are 0, negative 1/2, and then 1/2. So let's put them in order here. We would have negative 1/2, then 0, then 1/2. You wanted to write this as plus or minus 1/2, and then 0. Either way would work. Okay, so there's our 3 answers, which we should have expected to have 3 here. Okay, let's take a look at letter B here. It says 17x plus 7 equals 12x squared, so we should expect 2 answers here. But first, we need our equals 0, so let's go ahead and get that. We're going to bring this 12x squared to the other side. We have negative 12x squared plus 17x plus 7 equals 0. Now, you can do this, but it makes this first term negative, which I don't really care for. So let's actually switch all of our signs. We're going to multiply everything by negative 1. Obviously, we got to do it on both sides to make it legal. Just because I don't like this first thing being negative, and it makes things a little bit more difficult. So negative 1 times negative 12x squared is a positive 12x squared. Negative 1 times 17 is a negative 17x. Negative 1 times 7 is a negative 7. And then negative 1 times 0 is 0, of course. So I've basically just switched all my signs. If they were positive, they are now negative. And if they were negative, now they are positive. And if you notice, actually, I could have just brought the 17x and the 7 to the other side. They would both be negative, and, we'd have 0 up front, but you could easily move that to the back. So either way you want to do it, I would really, really recommend having this first term being positive, though, because if it's negative, it's just going to be a little harder to factor, okay? So let's go ahead and do our factoring. So first things first, GCF. We have 12, 17, and 7. No good. X squared, x, and nothing, so no GCF. Special pattern, square root of 12, square root of 7, no. So we're left with guess and check only. So here we go. Let's make our 2 binomials equaling 0. So 12, we have 1 and 12, 3 and 4, 6 and 2. Let's go ahead with 3 and 4. I like using those first. 7 though, we just have 7 and 1, so let's put a 7 here, a 1 here. Without doing signs, we have 3x times 1, which is 3x. 7 times 4 is 28x. There's no way that's going to make 17. So let's go ahead and just switch the 7 and the 1. See what happens there. So 1 here, 7 here. So 7 times 3 is 21. 4 and 1 makes 4. 21 and 4 could get us to 17. So I need a negative here, which means alternating signs. I need my bigger thing being negative, so that would make this plus and this minus. Let's just double check. 3x times 4x is 3x times 4x. So 3 times 4 is 12, and then x squared. 3x times a negative 7 is a negative 21x. And then 1 times 4 is a plus 4x. Negative 21 plus 4 does give us a negative 17x. And then 1 times negative 7 is negative 7. So we did factor correctly. So that's good. Now you have to be careful because a lot of people, they're so used to just factoring it and leaving it there and leaving it done, think that this is going to be their answer. And they're going to say yes. Just box that up and call it a day. Well, no, because we didn't find any solutions yet. We're close, but we need to get down to an x equals something. So don't stop here just because you're used to factoring it and leaving it. We actually do need to find our solutions. Now, if you're looking at these, this is going to be a negative 1 over 3, so that's going to be one solution. And then the other one is going to be a positive, because it's opposite this, 7 over 4. Now let's just double check to make sure. Let's set each of these things equal to 0. Make sure I did it right. 3x plus 1 equals 0, and then 4x minus 7 equals 0. Here we subtract 1 from each side, we get 3x equals 1. We divide by 3, we get 1/3. So I did get that one right. Here we would add 7, so we have 4x equals 7, and we divide each side by 4, so this would be 7 over 4. So yeah, those are my two answers. So like I said, if you can skip the whole let's set it equal to 0 part and just look at these and tell me your actual answers, then you don't need to show this anymore. If you need to show that part because you don't know how to look at these and tell, then that's fine too. I'm not mad at you for showing work. Never would be. Okay, so just, there are shortcuts here that do work most of the time. Or I'm sorry, all of the time. But if you want to show your work, then I'm not mad at that either. Okay, here's one for you to try. Just one. So give it a shot and come with your answers to class tomorrow so I can check to make sure you've got these. Thanks for your attention today.